this lesson a little bit, make sure you guys are kind of comfy. What I've done here is I've shown you that the data in this table, when plotted in a scatter diagram, looks like a linear relationship. It's not making a perfect line. Sometimes it may not even be a function because some points may stack on top, but it does have a linear relationship. So the first part of this lesson is that you could just grab this point right here, this point right here, and since you have 2 points, you could find the slope. You could go ahead and find point slope form and then down into slope intercept form. So actually, let's just do that. Let's just practice that. So that would be here and here. So basically, those are the ordered pairs, -30, 10, and then the other one is -14, 18. And I just picked this point and this point. You could have picked these two, any 2 points. So basically, the slope is going to be equal to 18 minus 10, which is 8, over -14 plus 30, which is 16. So we are going to get a slope of 1/2. So that means if I go to point slope form, y minus 10 equals 1/2 times x plus 30. And crank this out. Y minus 10 equals 1/2 x plus 15. And then y equals 1/2 x, add the 10, plus 25. So what this is we call this is our linear regression line based on these 2 ordered pairs. Now, if a company had this and it was an application and they wanted to make predictions of maybe something that would happen over here on the x-axis, then they could use this equation. That's the point of this, is to come up with a line that could predict future behavior. Okay, so that's how we do this one by hand. And we do want you to get the habit of being able to do it by hand. But what the calculator can do is consider all of the ordered pairs and actually calculate a linear regression based on all of the ordered pairs. So when you do this for this problem, and I'm not going to do it, I'm not going to show you here, I'll show you on the next one, but this one actually comes out to y is approximately 0.44x and then plus 23.46. That's what the computer is going to come up with, the calculator is going to come up with. So very close to 0.5, very close, but the blue here is more accurate. And obviously, we want to be more accurate if we can. Okay, so the biggest thing here is if you're going to do this, you have to go to a new document and you have to add a list in a spreadsheet. So I'm going to show you how to do this on the calc, but what I've done is I've pre-entered in this table to save time. So when I go to the calculator and show you this here, this calculator, if I go to my current document, I have it all entered in the table. So again, you have to pick lists in spreadsheet, but then when you get here, whoops, there it is. I have all of this entered in. So you got to put your x right up here, okay? You got to put your y right up there. So x and y have to go up here. You can name them different stuff if you wanted to. I typically pick x and y because this is our x and this is our y for this. This is what we have going on along the x-axis if we were to graph it, and then the y-axis here. So here's the deal. What we would do is we would fire all those in, make sure they order all the way down. Okay, but then from here we want to go to our menu and we want to go to statistics and then to stat calculations, and this is a linear regression. We will do some of these other regressions this year, but since our data is forming a line, we want the mx plus b form, slope intercept that we're used to, and I'm going to click on that. Now the only thing that's not in your notes is you do have to click on here and select the x, because that's what we called that column. So our x list is x, and then we want to select the y, our y list is y. And that's all you have to do. Now the cool thing I'm going to show you here is this says save the regression line to F1. And I'll show you what that means. That's going to spit it out to F1 of x so that we can see it on a graph. So I'm just going to click OK. And you'll see what happens here is we have, all right, you want a slope intercept form, mx plus b. Here's your slope, and here's your y-intercept. So using that information, we can basically real quickly say, hey, y is approximately, go to your slope here. There's the m right there. That's our slope. And I'm going to call it what? 0.012 to 3 decimals there, 0.012 x. And then we're going to tack on our y-intercept, which would be 5.5. We could call that there. Now, I'm hoping I put in my data correctly because I think that's a little different than I got a second ago. I'm just going to check this. 35, 5.88, 50, 5.99, 75, good. Be patient. Thank you for your time. Okay, my data's in there good, so it looks like we are good there. So that right there is our regression line. Okay? So now, that means that this would be the line we would want to use here to make predictions. So here's a couple of things that are really cool I want to show you on the calc here. It says predict the drilling time if the drilling starts at 135 feet. So I wanted it to be a little bit different than the table. So we don't have that in our table, but using our regression, we can actually calculate what that is. So I'm going to show you two ways. First of all, right, both on the calculator. From this page, if we do doc and we do insert and we do a graph, okay, our graph here says f of 2. If you go up 1, remember when I said it exported it to F1? There it is. That's the function 1. It already, see that? That's our linear regression line. And all we have to do is hit enter and it will graph that line. Now that line right there looks like a horizontal line. It doesn't look real great, but the problem is, look at our x values and our y values. Our x values go up to 190. Our window here is at -10 to 10 for the x values. So I'm going to go into the menu here, and I'm going to go into my window settings, and I'm going to change them. I want my x min here to be, we'll make it 30, because the lowest our x values go are actually 35. My x max, if you look at this, x max is 190, so I'll set that at 200. Y minimum, let's just set it maybe a 0 to 10 window, because that'll capture everything in there. So then when I click OK, this window is going to look drastically different. Now I'm going to pull this label away. I like to get that away from there. But here's the thing that's really, really cool, and this is in your notes on the front page. But if you go to Menu, and you go to Geometry, and you go to Points and Lines, and you put a point on, you can hover over here, and as long as you double click, you will get a point on there. Now be careful, see this little tool on the left? I'm going to hit the escape button to get rid of that tool, but this tracks all of the ordered pairs on there. So since this question said x value of 135, they were talking about this column predicting that column, so I can literally just double click that and I can type in 135 for my x value, and when I hit enter, it jumps right over here. And it tells you the answer to this question. It says it will be approximately 7.1 minutes. So we can get our answers right off of that. Now, another way to kind of do this is kind of neat. Watch this. I think this is neat. Go back to here, and instead of doc, insert a graph, I'm going to have you insert a calculator. And what you can do now is you can type in F1, because that's what you exported it to. It was called F1. So you can do F1 of, and you can type in 135. And then when you hit enter, it's going to say, oh, there it is. That's the value when you define this function at 135, because your calculator has that function stored in there. Pretty neat. Okay, then the next question, it's kind of cut off down below here. But basically, let me minimize this so you can see it. So this says predict the depth. So predict this, x, when the time is 7.7 minutes. So based on our function, we can do that. Now by hand, we could put the 7.7 here and solve for x, but this is rounded and it's not going to be exact and it's going to take time. So look at your calculator. We can go to that other tab where we had this value, and instead of plugging in the x, we can just plug in the y. And if we type in 7.7, because that's what the question says, and hit enter, they're going to say, oh, 186, which obviously over here stands for 186 feet. Okay, so that's a really cool way to kind of jump around, show you different things, and hopefully the functions are making sense how they're going together. Watch that again. Hopefully it helps.